Hello guys, in this video tutorial I will be taking care of a new proximity sensor, that is TMD2772. And to gain more knowledge about this sensor, let's go to controleverything.com, and here we have to search for this particular sensor, and let's see what we else got for this. It says that it's a digital ambient light and proximity sensor, and these are some of its more features as you can see on my screen. You can also purchase the sensor from this very site, from here. Now I will be interfacing the sensor TMD2772 with a Raspberry Pi and a Python code, and for that let's go to resource tab, and here comes the Python code sample. Now you can download the Python code sample from there. It's a zip file, it will be a zip file, and after that you can also download the code for the second option, which will be github.com, and the repository there is control everything community. Now what we require is to have a look over hardware connection, and let's see what we got there. In the hardware connection segment, first of all the requirement is of a Raspberry Pi, which you are able to see on my screen, and this here are the GPIO pins of the Raspberry Pi. Now this here is an I2C Shield, which you are able to see on my screen, and this is very useful in making connections with other I2C devices, and the connection are a lot easier. This is also available on the website controleverything.com. Now gently place this I2C Shield over the GPIO pins of the Raspberry Pi and make a connection. Next we require our sensor, that's the proximity and ambient light sensor TMD2772, and this here is a connecting cable. Now make the connection of the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the same reason I2C Shield. Now next we require a micro USB cable just like this, and gently insert it over the power jack. The last thing we need is to make an internet connection, and for that there are two mediums. The first is an Ethernet or a LAN cable, as you can see, and gently insert it over the Ethernet jack. The second is an wireless USB nano adapter, which you are able to see, and it is also very handy. Now we are done with the connections part. Now what do we require is to have a look over the code, and let's interface. Now for the interfacing part regarding the Python code, let's log into github.com, and here we have to search for the repository, that is control everything community, which you are able to see on my screen, and click over it. And this sensor is the required sensor TMD2772, and here it is, the Python code. Let's have a look over the instructions first. We have to download and install SMBus library on the Raspberry Pi, and the steps to install are provided on this link. Let's open up this link, and let's have a good look over the installation procedure. Please note it down, the relevant information clearly, and do the installation carefully. After that, this is the code and this is the command to run the code, as you can see. Now get back to the code, and it's a .py extension file. Now in the code, as you can notice, we have imported SMBus and time libraries, and we have the address of the sensor, that is 0x39. Now in the writing section part, we have selected enable register 0x00 or with command register 0x80, and we are sending a command that will be 0x0f for power on, wait enable, proximity enable, ALS enable, and the writing command is here. Then we have to select ALS time register 0x00 or with command register 0x80, and it will be, the command will be 0xff for time equal to 2.73 ms. It's the A time. Then we have to select proximity ADC time register having address 0x02 or with command register 0x80, and we are sending a command that will be 0xff for P time, that is 2.73 millisecond, and the writing command is here. The second last command, and here we are selecting wait time register having address 0x03 or with command register 0x80, and we are sending a command that will be 0xff for W time, that is 2.73 millisecond, and it will be command here. The last command, as you can see, we have to select control register 0x0f or with command register 0x80, and we are sending a command that will be 0x20 for 120 milliampere LED strength. Proximity uses channel 1 diode. Proximity gain and ALS gain are 1x each, and the command is here, as you can see. Now we have seen the writing part. Now let's read some data back from the sensor. As you can see, we are reading data back from the sensor from the data register, that is 0x14 with command register in OR condition, that is 0x80. 6 bytes we are reading for channel 0, channel 1 and proximity data. After that, we are converting the data. As you can see, a lot of formulas and if condition is used, which is clearly described in the data sheet for 2772 TMD that well. And at the end of the code, we have the output data on the screen, which you are able to see on my screen, which is ambient light, luminance in lux, and proximity of the device. So this is how the sensor is. Now what do we require is to show the practicality, and let's have it. For the working environment, first of all, the step is to copy the entire code of the Python, as you can see on my screen, and then we have to open up the terminal for the Raspberry Pi, and here we have to create a new file. As you can see on my screen, .py will be the extension, and here we have to paste the entire code, and after that we have to save it, and then this is the command to run as the code, as you can see, and .py will be the extension. And it says that we have the ambient light, luminance, and the proximity of the device, which is clearly shown, and there is no change. But when I place some object over the sensor, you can see the ambient light and the proximity decreasing. Now instead, when I put a light source near the sensor and run the command, you can see the increase in ambient light, luminance, and the proximity of the device. So this is how the sensor works. Now what do we require is to see the benefits, applications, and the features. Let's have it. The TMD2772 family of devices provide digital ambient light sensing, a complete proximity detection system, and digital interface logic in a single 8-pin surface mount module. The TMD2772 enables accurate results and approximates human eye response to light intensity under a variety of lighting conditions. The proximity detection system includes an LED driver and an IR LED, which are factory trimmed to eliminate the need for end-equipment calibration due to component variations. The applications for the TMD2272 includes display backlight control, cell phone touchscreen disable, mechanical switch replacement, medical diagnostics, and a lot more. This sensor is available on the website controleverything.com, and you can purchase it from there. Also, you can have the code from the resource tab, and after that you can download the code as a zip file from that very site. You can have the code from github.com also, and the repository there is Control Everything Community. In the end, I would like to make it clear that for any further clarifications and queries, you can reach us on controleverything.com, and you can post your comments on the community page. For articles and blogs, you can reach us on instructables.com, and if you want to subscribe more video tutorials like this, go to our YouTube channel. I hope you enjoyed this video and had a good fun yourself. Thanks a lot for watching.